So we're going to do linear algebra. So in linear algebra, we are going to start with a chapter for matrices. For matrices. So with the chapter for matrices, I will start by introducing what you did for in grade 12. In grade 12. So you used to work with a simultaneous equation. Simultaneous equation. Simultaneous equation. So when you work with simultaneous equation, you will be given maybe x, it can be plus 2y, let's say equals to 5, maybe 2x plus y, which is equals to 10. So this one is going to be your equation 1, and this one here is going to be your equation 2. So when you solve this simultaneous equation, normally you will check one of x variables, then you'll check maybe x and 2x. Then you're gonna multiply equation 1 by 2. So when we multiply equation 1 by 2, you will get 2x plus 4y, which is equals to 10, which you're gonna make it to be equation 3. So now you will take equation 3, you can subtract with equation 2. So when you subtract with equation 2, you will get 2x minus 2 is gonna be 0, plus 4x minus y is gonna be 3y, which is equals to 10 minus 10 is going to be 0. And when you get 0, it implies that your y is going to be 0. Then you will substitute in one of the equation. You can choose maybe equation 1 or equation 2. Then you're gonna substitute the value of y. So if we use equation 1, then you're gonna have x plus 2, which is 0, equals to 5. So this implies that your x is going to be equals to 5. So now the point or the values that you have, you're gonna have 5 into 0. So this is your point. So now here in linear algebra, we are going to use a matrices. We have the first one, we call it a gaseous elimination. So with gaseous elimination, this matrix, we can rewrite it as 2. It was 2. Okay, it was x. For x here, the first one was 1 for x side, and y side here. You don't really have to indicate x and y. I'm just indicating them so that you can see what's happening. It's gonna be 1 and 2. And the other one, the other value is 2x and plus and y. It's gonna be 2 and 1. So we're gonna write just a line. Then we write the value we have for after this one is 5 and 10. It's 5 and 10. It's 5 and 10. So when we write this, so with gaseous elimination or row economy, this is a row. We call it a row. It's a row. And going up there, it's a column. So now when it's a row, we're going to say, you say 2 times R, because it's the first row. It's like this is a first row and it's a second row. You're gonna say 2 times R1, maybe minus R2 is going to give you R2. So when we do that, when we multiply, you're gonna write 1 and 2 there, given is 5. Then when we 2 times R1 minus this one, is going to say 2 times 1. Here is going to be 2 minus 2 is going to give us 0. If we say 2 times 2 is going to be 4, minus this one minus 1 is going to give us 3. Then if you say 2 times 5 is going to be 10, minus 10 is going to give us 0. So now by doing this one here, this implies that you can rewrite this as x plus 2y equals to 5. And then for 0, we just ignore it. We're going to write 3y, which is equals to 0. So now when we solve it, there is we use a backwards substitution. Then the backward substitution, we're going to divide by 3 both sides. Then we're going to get y. This one, we call it a backward substitution. Backward substitution, we're going to get y equals to 0. Then when we get y equals to 0, we substitute back to this equation, which is x plus 2y equals to 5, whereby we're going to get our x plus 2 in brackets 0 equals to 5. And this will imply that our x equals to 5. So just by doing that, we have solved the value of x, which is equals to 5, and the value of y equals to 5. So this one is just an introduction of how things are going to be working, how we are going to work with a linear algebra in this module. So now we are going to start with introduction to a limit. Introduction to a matrix. So if I have a matrix, I can write it A11, A12, A1, A21, and A22. So this is a matrix of a 2 by 2. So in this matrix of 2 by 2, it have a row. A row is a line which goes from this side horizontally, and rows that are going vertically, and the lines that are going vertically, we call them columns. So it starts with a row M multiplied by N. M, this N means for row and the M means for column. So when you have this matrix here, the matrix, it can be composed of numbers. So the side of this side, it can be maybe A1 or A2 like that. Sometimes it can be for X and Y. It depends on the type of a matrix that you're going to work with. So we also have a matrix of it can be 2 by 3. A matrix of 2 by 3, we write a multiply by 3. It's a matrix whereby it have 2 rows and 3 columns. So a matrix of 2 by 3 is going to be in terms of A11, A12, A13, and A21, A22, and A23. So this, in this matrix, everything that is inside there, they are coefficients of the matrix. So now this matrix that I just wrote is a matrix of 2, a row of 2 by 3. So now in this one, we are going to be solving things that we have to first change in a matrix. So according to the definitions, here we're going to be working also with definitions, but more of the first, because you are doing a first year module. For first year, you guys, you need to be only knowing the practical part, most of the practical. The definition will find the most of to know about the definition when you are second year and final year. So if you see some videos, I will send you maybe some videos if you want them, but you don't have to look at it, but you can just have a look, but you don't have to remember everything, because it's a final year module and second year, so that you can see where you're going to be going, or you can check in my YouTube. They are also there, I upload them. So we are going a matrix. It can be something that we're going to be when 1, X, for example, plus, let's say 1, 2, Y, plus 1, 3, Z, Z, which is can be B of 1. And then this one here, when we another one, let's say it can be 1, A of 2, 1, X plus A of 2, 2, Y plus, let's say, A of 2, 3, Z, which is equals to be 2. Then another one is gonna be A3, 1 of X plus A3, 2 of Y plus the A of 3, 3, which of Z, which is equals to be 3. So when we write this, these are coefficient of this linear system. So now what I'm doing here, this is a linear, we call it a linear system. So in this linear system here, we can write this as the coefficient when we reduce by using gaseous elimination. We can write the coefficient of this matrix can be 1, 1, A, 1, 2, A, 1, 3, and then it can be equals to A, 2, 1, A, 2, 2, and A, 2, 3, A, 3, 1, A, 3, 2, and A, 3, 3, which is equal to B1, B2, B3. So when I have written this one here, this matrix we can let this side here, which I've written, to be equals to X, and we can let this be equals to B. So this is the matrix of X over B. So X over B. So when we write it in the form of, if we want to solve this matrix, we can just write those values again, those coefficient, same time. Okay, I'm just gonna be fast because they look similar what I'm doing. 2, 1, this is 2 here, A, 2, 2, and A, 2, 3. Then you write a line with B1, B2, and B3, which is going to be A, 3, 1, A, 3, 2, and A, 3, 3. So this is a reduced way. So now when we have this, we are going to be needed to solve this kind of a matrix. It can be 2 by 2, 3 by 2 by 3, or 3 by 3 matrix, or even 4 by 4. So now we're gonna start with the additions of a matrix and the subtraction of a matrix.
Hi. What's happening? Network mo kikile out.
Only display battery flat. So that means to charge. And he's coming back.
Motho laptop ya gage mo fa bothata the whole weekend e ntse e ira di on and off tseo during the class.
Yeah. No, he has to Adula channel.
I forgot. Hello?
Yesterday.
Yeah, I'm here, ne?
Okay.
Can you see my board?
No.
Hello?
No, we don't
Okay,
see your board.
All right, let me try to check. Stop. Share screen. Or let me just use this whiteboard in there. Or I don't like it. Can you see the whiteboard in my with a pen? Oh, I didn't share the entire screen. Yeah, can you see the whiteboard now?
Yes.
All right. So as we are still saying, so we are going to be in this matrix. I'm used to my now. Okay? So in this one here, we are going to be in a matrix of 2 by 2, the one for A11 and A12 and A21 and A22. So this is a matrix of 2 by 2. And if we have another matrix, let's say we are adding them, it's a matrix of, I'm gonna use B1, 1, and B1, 2, and then B2, 1, and B2, 2. Then when we add them, we add, for the first value here, we're gonna add, I will indicate, put the brackets, we're gonna be A11 plus B11. This is for the first one, and then for the other one is gonna be A12 plus B13. Just let me just record this class. I think it's recording. Let me just record. Okay. Oh yeah, it's recording. Then after that, for the second one, we're gonna have A21 plus B21, and then the second one is gonna be A23 plus B22, not 23, is 22. So this is how we add them. So the same applies with the subtraction. So let me say if you are adding plus or minus, I can just say plus or minus here. So now if I can do a countable example, I will do a countable example. If I'm having a matrix, let's say it's 1, 2, 0, and 1, and I'm adding them with 0 plus, okay, 0, 1, and 1 and 3. So these two matrices, when I add them, is going to be 1 plus 0, 1 plus this one, plus the 0 is going to be 1. 2 plus 1 is going to be 3. 0 plus 1 is going to be 1 again, and 1 plus 3 is going to be 4. So that's how simple it is when you are adding a matrix of 2 by 2. Even the matrix of 3 by 3, you use the same principles. So if you have, let's say, for example, if you have a matrix whereby we are multiplying them, if it's A11 and then A12, A21 and A22, you are multiplying it with B11. Before I proceed, let me just write here. When I write A11, this 11, it means the first row and first column. So when you see A21, it means that it's a second row and first column. So this is in second row and first column. This means 2, it means that it's in second what? It's in second row and second column. So that's why I'm using 2, 1 like that. B1, 2, it means that it's in the first row and second what? Second column. B1, B2, 1, and B2, 2. So if I'm multiplying these two matrices here, the first one, the equation here to get the first one, you take this row, go this way, and you go this way. When I say that, you're going to say A11 times B11, it's going to be A11 multiplied by B11 plus A11 multiplied by B11 plus A12 multiplied by B21. So this is one thing. Then when we want to get the second one, it's going to be A11. Let me just write this answer this side here because I don't have a space there. We got that the first one is A11 B11 plus A12 B21. Then when we want to go to the second one, we're gonna still use this one and this one this side, which is going to be A11 plus multiplied by A12 A11 B12 plus A12 B22. Then when we go to the second row, it's gonna be A21 A21 B11 plus A22 B. This is for the second row, we use this one line and go back like this. It's gonna be A21 B11 and A22 B21. You close brackets again, but these brackets I'm just using them to show you so that it's the same thing. Then we're gonna also have A21 B. From the second one we use this one and this side, a B12 plus A22 B22. So when we do a practical example of this, it's going to be so when we do a practical example, if I can give you guys maybe 1, let's say 1 0 2 1, then we are multiplying it with 1 1, let's say 1 1 2 2. So when I do that, if I want to get my first one, I'm gonna say 1 times 1 is 1 plus 0 times 1 is going to give me 1. Then to get this side is going to be 1 times 1 is 1 plus 0 times 2 is 0. Again, I'm gonna get 1. But let me just do it. Let me not just write like that. Let me do a bracket so that you can see. It's going to say 1 times 1 we're going to get 1 plus 0 times 2, we're going to get 0 with brackets, again brackets, 1, this one times this one is going to be 1, 0 plus times 2 is going to be plus 0. Then we come to the second row, 2 times 1 is going to be 2, and then 1 times 2 is going to be plus 2 again, close brackets, and then 2 times 1 again is going to be 2, 1 times 2 is going to be plus 2 again. So this matrix is the same as equals to 1 plus 1 there is going to be 1, 1, 4, and 4. So this is the matrix when the results of this matrix when we are multiplying them. So if you have understand this, so it means that you won't have any problem when we are dealing with a like multiplication of a matrix. So sometimes also you might be multiplying the matrix of 3 by 3 and then or maybe 4 by 2 by 3. It depends on the question, but you use the same process that I've given it to you. If they gave you maybe a matrix, for example, okay, let me open your book. If they give you maybe a matrix, let's say is 1, 3, 4, 0, 2, 1, then you are multiplying it with a matrix of 1, 1, 2, 0, 3, and 2. So the same process applies. You're going to say 1 times 1 is going to give you 1. This is 3. 3 times 2 is going to be plus 6. Then 4 times 3 is going to be plus 12. Close brackets. When we want to come to the second row, it's still the same. 1 times 1 is going to be 1. 3 times 0 is going to be plus 0. 4 times 2 is going to be 8. This 4 here, you multiply with this one. Then we go to the next one. You can say to the next one, you can come with this one here. 0 times 1 is going to be 0. 2 times 2 is going to be plus 4. 1 times 3 is going to be plus 3. Then we go to the next one. 0 times 1 is going to be 0. 2 times 0 is going to be 0 plus again 0. 1 times 2 is going to be plus 2. So when we conclude this one here, we can write it as 1 plus 6 is 7. 7 plus 12 is 19. And then 1 plus 0 is 1 plus 9, 8 is 9. And then 0 plus 4 is 4 plus 3 is 7. And then 0 plus 0 is 0 plus 2 is 2. So the answer becomes like that. So you can see that when you're working with a matrix of 2 by 3 and you are multiplying it with a matrix of 3 by what? By 2, the final answer you get 2 by 2. A matrix of 2 by 2. So this is how, but the point I'm showing you this is for you to grab the formula of how you get the answer when you're multiplying the matrix. Still the same and the same. So now let's do this other one. When you have a matrix, it can be a matrix of 2 by 2, or it can be a matrix of 3 by 3. So if I have a matrix of 3 by 2 by 2, I can have A11, A12, A21, and A22. So in this matrix, if I have to solve it, I have to make sure that this side I must achieve 0. So in order for me to solve it, it must say I must be having this kind of a form so that I can be able to get these values. So if it's a matrix of 3 by 3, A11, A12, A13, A1, sorry, A21, A22, and A23, and A31, A32, and A3. So A33. So in this matrix, if I want to make sure that I can be able to solve it, I must make sure that this side going this way, this one must be 0, 0, 0. So in other words, you must be able to achieve something like this: A11, A12, A13, 0, A22, A23, 0, 0, and A33. So just by doing this, you can see we have achieved 0. So then it will be able to be solved. So now we're gonna do a countable example. So let's say I was given a matrix. I will show with this one is a gaseous elimination. We are dealing with a gaseous elimination. Let's say I have this matrix here is 2, 4, 6, given that is 6. Then I have 1, 2, and 3, given that is 3. Then I have 1, 1, and 3, given that is, let's say, 9. So now I'm asked to solve this matrix. This matrix, when they write it to you, they won't write it in this form. They will write it maybe as 2x. They ask you to solve this linear system. It can be 2x plus 2y plus 6z, which equals to 6. Sometimes they might not use, they can say, for example, they can say x1, x2, and x3. So just that I'm using x, y, z. So the letters that I'm using does not necessarily mean that they are going to be exactly the way I'm writing now. So it will also be written as x plus 2y plus 3z equals to 3. Then it can be written as x plus y. I'm just interpreting this plus y plus 3y plus 3z equals to 9. So now when you are given this, you must be able to reduce it, write it in this format here. When you write it in this format, now you can be able to solve it. So as I've indicated, this means it's a row 1, it's a row 2, it's a row 3. So we have row 1, row 2, row 3. So our objective now is to make this to be 0. So we need to follow the row column elimination by row column. We call it gaseous elimination. So for gaseous elimination, we are going to use a same. We're gonna check here in row 1. We have 2. So we need to make this one to be 0. So we can see that if we can say row 1 minus 2 row 2, we are going to get row 2. So this implies that I'm gonna say, all right, 2, 4, 6, and 6. So this one is gonna say row 1 is 2 minus 1 times 2 times 1 is going to give us 0. Then row 2 is 4. If I minus by 2 times 2 is going to be 4. 4 minus 4 is going to give us 0. Then row 6 is going to be 6. If I minus by 2, it's going to still give us 0. And then row 3 is 6. If I minus 6 times 3 times 2 is 6. 6 minus 6 is still going to give us 0. Then I can also, again, I say row 1, I subtract by 2, row 3 to achieve row 3. So this is what I'm writing. When you're answering a question like this, you must write them, because it's very important to show the steps that you have used in order to get the solutions. So now in this one here, the steps that I'm using here, I'm gonna say 2 minus 2, because it's gonna be give us 0. Then it's gonna be 4 minus 2. When we multiply 1, it's gonna be 2. It's gonna be 2. 4 minus 2 is 2. Then it's gonna be 6 minus 3. 3 is times 2 is gonna be 0. Then it's gonna be 6 minus 18. 9 times 2 is 18. 6 minus 18 is going to be minus 12. So when you achieve like this is a row of 0. You are allowed to exchange rows. When you exchange row, you can say, I'm changing row what? Row 2 to be changed with row 3. So when you do that for row 2, we have, let me write it here, row 2 to be changed with row 3. So we can recopy the matrix for 2, 4, 6, and 6 there. Then these two, when they exchange, we're going to write 0, 2, 0, and 0, and then 0, 0, 0, and sorry, this one is not 0, it's minus 12, sorry. Yeah. Then we're gonna change, we are changing these two rows, 0, 0, 0. So this matrix here now, you can see that if we divide in this matrix, you are allowed to say, I can divide. If like you have 2 here, you have 4, you have 6, you have 6, you can even divide by 2, you won't get the remainder. And even if here you have 2, you have negative 12, you can even divide by 2. So if we say row 1, we are going to divide by what? By 2, and then we divide by 1 over 2. By 2, we're going to divide by 2 to achieve row 1, and row 2 is still going to also divide by 1 over 2 to achieve what? Row 2. So in order for us to get that, we can achieve, we're gonna be 1, 2, 3, and 3. Then when we divide by 2, this row 2 is gonna be 0, 1, 0, minus 6, and this one is 0, 0, 0, 0. So in this matrix here that we have just achieved, when we solved it, we have achieved a matrix called a non-trivial. It's called non-trivial matrix. A non-trivial matrix is a matrix with which have a infinite solutions. So when you get a matrix whereby everything is 0, it will have infinite solution, whereby we have to let our, if it's x, y, and z, we're going to have to let our z to be equals to t. So when you let our z equals to t, then you will say your y equals to minus 6, because here your y equals to minus 6. When your y equals to minus 6, when we solve this one, you will say your x plus 2y plus 3z equals to 3. Then your x is going to be equals to 3 minus the other two variables, to take them to the other side. When you say minus, remember your y is what? Is minus 6. You substitute 6 there. Plus minus 3, your z is t. Then the answer for this one is gonna become is 3 plus 12, which is going to be 3 plus 12 is going to be 15 minus 3t. When we have 15 minus 3t, if you are solving, if you are writing your equation in terms of a matrix whereby your equation, it was x, you can say x, y, and z equals to, then your answer for x was 15 minus 3t, then for minus 6, and for z was t. So let me just erase here, and then I'm gonna rewrite them properly. So let me just write the final solution is x, y, and z. So here we got the answer for 15 minus 3t and minus 6 and t. So now in this equation, we can rewrite this as 15 minus 6 and 0 plus t in brackets. We are just solving, factorizing. It's kind of like a factorizing in a form of, in a style of linear. So it's going to be plus t. We can write minus 3. When you say t times 3, is going to give us minus 3t. For here, you can put 0, then you put 1. So this is how you can represent the solutions of your linear equation after finding them. So that matrix, remember, is non-trivial matrix. Trivial matrix. So now I'm gonna take one of the question in your textbook. Let me check which one we can use. So if you have a I'm gonna be back now. I just want to see maybe one question that we can solve together in one of the exercises. So if you go to page number if you go to page number 36, page 36, chapter 1, page 36 is exercise 1.3. You can see in exercise 1.3 in number 1, 2, 5, 6, 7. In number 6, I think it's 5. 5 is 2. Yeah, I think 6. Use the following matrix to continue the indicated expansion of it if it's defined. So we have those metrics there. So in number 3 there, you will find that we have the one for you have the one for d plus e. You can add them then, but I'm interested in checking the one which we can multiply, or the one which we can find the solution is not the right one. So I'm gonna skip that one there. Then in page number 37, you have, it says in each 37, number 10, in number 10, there is an arrow indicating that from 11 to 12, it says in each part of exercise 11 to 12, find matrix A and B and X and B that expand that, okay, express the given linear system as a single matrix equation, AX equals to B, and write out this matrix equation. So I'm not sure, do you guys have a textbook, right? The one I'm using.
Yes.
Okay, so if you go there to that page, which I show, the page asks us to write a matrix in the form of AX equals to B. So the matrix that we were given, the linear system that we were given, the first one from 11A, I'm just gonna do 11A, is 2x 1 minus 2, 2x1 is 2x1 minus 3x, I think is x2, yeah, minus 5 plus 5 x3 equals to 7. Then the other one is 9 x1 minus x2 plus x3 equals to -1. And then the other one is x1 plus 5x2 and then plus 4 x3 equals to 0. So now when we have to write it in this format, what happens is that we're going to first write the one for A, the block for A. This is the block for A. You just put 2 minus 3, the coefficients only, and 5. Then 9 minus 1. This is minus 1 here. And then 1. Then we're going to write 1, 5, and 4. Then we cycle it. Then you put again. So you put, it must not be like that way. I just made a mistake. Then you're going to say x1, x2, x3. This is equals to, then here you write 7 minus 1 and 0. So I didn't write it properly. Let me just try to be clear because I was checking this matrix, but I think you can see it. So exactly the way I wrote it, this is A, X, which is equals to B. That's what is needed for you guys to write there in that exercise if you open it. But I'm gonna try to find the one which we have to solve. So if you go to chapter number, if you go to 1.4, 1.4, they are teaching about the inverse algebraic properties of a matrix. So you already know how to add the matrix and then how to add how to multiply them. I already told you how to do that. So I'm gonna get a matrix, one matrix that we're gonna use to maybe to solve it. But now I'm going to talk about something. There is something called identity matrix. It's represented by I. So identity matrix, when it's represented by I, if it's for 2 by 2, it's going to start, it can start with A 1 1 and it must have 0 there, and it must have 0 here, and maybe A 2 1 2 2. So in terms of number, when we write not really 0, let's say it will be, this is wrong. The identity matrix, it must be equals to, is 1 0 0 1. Like that is. This is an identity matrix. This is what we call it, an identity matrix. So in identity matrix, even if let's say this is for 2 by 2, then the identity matrix of 3 by 3, gonna be 1 0 0 0 1 0 0 0 1. So with identity matrix is going to help us when we want to find the inverse of a matrix. When we want to find the inverse of a matrix. So now if we move to this one here, I'm looking for a question that I can multiply. I'm not getting that question in your textbook. So I'm just gonna use one. Okay, it's fine. So I'm just gonna, in exercise 11 there, I think I'm gonna just try to do it. Yes. So in the exercise that I was doing, 11, we have indicated that I've written it in terms of how you can solve it. So now I'm going to write it in terms of solving it so that we can solve together. You see how we do it step by step. Then we're gonna move to the other chapters of the determinant and the inverses. This is 2 here. It's just the same matrix, but I'm just answering it, showing you how to prove, how to make it, how to solve for it, even though it's not, its purpose was not meant for solving. This is 1, and my 5 and 4, and it was 0. Yeah. So now when we've solved the same process that we were doing, we're gonna say, okay, for us to achieve 0 here in 9, we can multiply equation 2 by 9. If I multiply equation 2 by 9, R1, this is, remember, it's R1, R2, R1 by 9, then I subtract it with, if I multiply R1 by 9, it's going to say 2 times 9 is going to say 18. Then I subtract with 2, R2 to achieve R2. So for this one here, I will multiply, I will say R1, I can subtract with 2. I multiply it by 2. If I multiply by 2, R3 to achieve R3. So I'm gonna get 0 there. So now we can solve it. This one, we know that we're gonna write as it is 2 minus 3, 5, given 7. Then here is going to be 0. So we are going to follow this formula. 9 times 2 is going to be 18. 2 times 9 is going to be 18, which is going to give us 0. Then we're going to say 9 times minus 3 is going to be minus 27, minus 2, minus 2 times minus 2, minus 2 times minus 1 is going to be plus 2, which is going to be 27 plus 2 is going to be 29. Then 5 times 9. What is 5 times 9? If you say 5 times 9, let me use my calculator. 5 times 9 is 45, which means it's gonna say 45 minus 2 is going to be 43. Then 7 times 9 is 63. 63 plus 2, because it's going to say minus 1 times minus 1 times 2 minus 2 is going to be 63 plus 2 is going to be 65. Then even still the same, we use the second one is going to be 0 here, because it's going to say 2 minus 2. And then after that, it's going to say minus 3 minus 10. 5 times 2 is 10. Minus 3 minus 10 is going to give us minus 13. Then you're gonna say 5 minus 4, 5 minus 8 is gonna be minus 5 minus 8 is gonna be 5 minus 8, 5 minus 8 is gonna be minus 3. Then 7 minus 0, 0 times 2 is 0, 7 minus 0 is 7. So now we have achieved, we are only left to deal with this one here so that we can eliminate to be 0. So now we have in our area, in order for us to achieve that, we are going to multiply R2 by 1 over 13. And to achieve, we add it by, because here is plus, we're going to add it by 1 over 29 R3 to achieve R3. So we're just going to write the matrix as it is 2 minus 3, 5, given 7, and then 0, 29, 43, and 60. Is it 65? 65. Then here we know that we're going to get 0. With this calculation, we still know that it's already 0 times 0 is 0. 0 times 0 also is 0. So even here now we know that when we use this formula, because this point of multiply by 13 is that 29 and 18, it's not easy for us to get the coefficient. So we just take this one, we multiply by it on 1 over, we just say 1 over 13 multiplied by this one is going to give us, this one here, if we multiply, is going to give us 29 over 13. 29, okay, it's going to give us 29 over 13. Here there is a, when we say plus minus 13, it's going to be minus. Again, we multiply r what? Our r2 by 13 by 29, which is going to be 29 again over 13. So 29, this one will cancel with this one. So when it cancel with each other, so normally which I used multiplication, I used a 1 over. So the 1 overs, they will not be, it must be only 13. You're not supposed to, it must be only 13, and here it must be only 29. We just write 29 there. 13 and 29 is going to say 13 times 29 and 29 times 13. You can see that here we're going to get 0. Then here now you're going to say 13 times 40, 43. 13 times 43 is going to be 559. We plus, because we are adding here, we check the sign there is what? The sign here is minus 3. Then which means it's going to say minus. Then we say 29 multiplied by 29 multiplied by 3 is going to be 87 minus 87. So if you get the answer there, you're going to 559 minus 87. It's going to be 472. So it's 472, which is equals to, now we're going to say 65. 65, you multiply it by 65 multiplied by 13, you're gonna get 845 plus 7 times 29. 7 times 29 is 209, 203. So if we add them, 203 plus 843, 45, sorry, 45. Then we're going to get 1048. So now we can do a backwards substitution. The backwards substitution is going to say, for this matrix that we're working with, it was based on x1, x2, x3. It's going to say 472 x3 equals to 1048. Then which means your x3 you divide, It's going to be equals to, you can use your calculator. I'm not going to use your calculator now. 48 over 472. Then to substitute back here, you're going to have 29 x2. X2 is going to be equals to 65 minus 43. In brackets where there is x is x3, we substitute 1048 over 472. Then after that, when you have given that, you can divide by 29 to get, you divide everything there by 29. Then when you get the answer, your x1 is going to be equals to 7 minus 5x3 plus 3x2. You divide it by 2. Then you just substitute the values, then you're going to get the x1, x2, x3. So this is how you solve it based on this method of gaseous elimination. Any question? Anyone have a question based on what we're doing now?
No.
All right, if you guys, you are satisfied, you don't have a question, then for